I mean, I did when I was a kid, just 'cause I remember feeling like, oh, I'm being made to go to piano lessons, but then that's how I learned how to play percussion. But I wish I still played piano. All right, let's look at these results here. One of us thinks package A uses the least cardboard. Guys, this is kind of like it's not kinda. This is what Amazon does. And what's so funny is my wife orders books all the time. You can stop whenever you would like. No, that was me talking to my wife through YouTube. But like her books keep coming in different sized packages. Because I think the computer is like trying to figure out what's the best efficiency. Because think about it, they gotta make those packages, not buy. Amazon makes their own cardboard at this point, right? They make their own packages. So which of these uses the least cardboard? Because they're all actually shipping the same amount of candy. Who's ever gotten an Amazon package, you open it up and you're like, what the heck, this is stupid. Yeah. Whatever packaged this wasted a bunch of space. Or they put a box inside of a box. I got that. Now, there is an option on Amazon where you can say just ship an original package, and they won't put the box in the box. You can save a box that way. But I guarantee you, I promise you, these do not all use the same amount of cardboard. Which is what a lot of us feel, is that all because they all have the same amount of candy inside of them, you're thinking they all use the same amount of cardboard? That just ain't true. Go ahead and keep going. You don't have to change that answer. It doesn't matter if you get things wrong in Desmos, but I'm telling you, it's not true. They are not all equal. All right, so for those of us that actually made a vote, package B, it's a bulkier shape, so it has less surface area. This is evidenced by desert animals having lankier... Wow, we went deep into the science, like biology on this. Okay, that's impressive. All right, let's pay credit to that. Harrison, beautiful answer there. Great work, man. Read Harrison's answer. If you. All right, it's anonymized, but I'm just going to give credit where credit's due. Harrison went into a whole biological relationship there. D seems the smallest and is shorter. D seems the shortest, most compact. Looks. I read the question wrong. Oops. Package D has 20 area. I don't know what that means because area is not a label. So I don't quite know what 20 area means. They all use the same amount of cardboard. It was shown in the video. That's not true. They're all the same amount of candy, but they don't all use the same amount of cardboard. You are making an assumption. I don't even want to read all these because we're assuming some not correct things. If we have a box, right? If we have a box, and our box has a front. Now, box, not meaning cube, right? There's a difference between a box and a cube. If we have a box and it has a front, what does it also have? A back. If it has a top, a bottom. If it has a right, so when you get to calculating or figuring out some of their actual surface areas, if you get the front, that's the same as the back. If you get the right, that's the same as the left. If you get the top, that's the same as the bottom. That's the dimensions of the box. So you can change this to show those dimensions if you want. So the 2411, that's the super long. It was all 24 cans in a line, right? So you got to think about it as a box. Hey, it seems like some of us are not realizing the interactiveness here. This can be changed to represent whatever dimensions they give us. So that first box they talk about, and maybe one of you has counted, is this 24 if I just make it as wide as possible? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. But this is asking us total amount of cardboard to wrap this up. Now, somehow, because we're at Wonka's factory, we don't need any overlap. You know how normally boxes get glued together and there's some overlap? We're assuming somehow magically all the edges just like, they're like welded together, right? The cardboard is, it's all perfect. There's no overlapping edges. We're going to consider this like perfectly optimized boxes. So I'm pretty sure on this box, I need 24 on the front, 24 on the back, 24 on the top, 24 on the bottom, but there's still ends. We got to think about both ends. If you care, some of us that are beyond that slide have incorrect answers. I don't think it's giving you the feedback. It's giving me. So if you want to see if you're right or wrong, you can come up and check with me. I'm not going to make you go back and recalculate it because this is just for us to play with. I do want us to maybe have some aha moments though, so I am going to sync y'all to me. Oh, I'm so sorry. So if I were to do, let's do one of the more interesting ones. Let's jump down to the bottom box. I want to do 6 by 4 by 1. So here, the face facing us, and you guys might want to have some paper out to jot some things down. The area of the blue face, well, we can just count that. How much is it? 6. But there's a back that is the same size. So if I'm writing this down, what I'm probably writing down on my graph paper, because we all love graph paper. Oh, I should plug in my document camera. That would be helpful. Yeah, I'm making you all stuck on this slide for a minute, because those of us that have moved past it got it wrong. So my front and back, gravity works. That's going to be the 6, but then times 2 because the back is also 6. So that's 12. My top and bottom, and you could be writing this stuff down. I'm not going to make you, but you'd be better if you did it. If the top is 6 by 4, how big is the top? 24, right? But if the top is 24, what else? The bottom is also 24. So that's 48 there. I've done the front and back. I've done the top and bottom. What do I need still? The right and left, right? Left and right. So what I can see is my right face. That's 4 by 1, right? How big is that? 4, so I could do 4, but then the left is also the same, so I double it, and I get 8. So when I put all of those together, 68 should be the surface area of that final option. All right, I'm going to unsync you so you can keep going on your own, but I mean, it's only one of 4. Hey, Jack, I don't think that's helping you. Well, what he was doing.
Yeah.
If you didn't get the notes from the back, you're going to want to at some point. They've got pretty pictures of shapes on them. There's still some discrepancy on whether package B or package D will use the least amount of cardboard. So you might want to be really careful comparing B and D. Our votes are kind of split on slide 5 where we make a second vote of like now that we've done the math. So be careful calculating your B and D. I'm not going to tell you guys who's, I mean, we did D together. But you got to be careful as you're doing B. All right, I gotta pause my recording, but that is the course challenge. So we're gonna talk about that in a second, but don't go too deep into content. Everyone look at your notes, and if you still don't have a set of notes, I don't know why, because I've asked you to get them like 3 times. Awkwardly staring, awkwardly waiting. All right, Harrison, I believe you. My front row dudes, I don't know that I believe that they could have not heard me. 3D objects. I know on your paper it doesn't quite look like 3D because the hole punch, and I think the copy machine has it out for me. So if you need to write a 3 on there, you can, but it's pretty obvious what we're looking at are 3D objects. Now here's the main thing about this worksheet is talking about volume. So first things first, if we're going to talk about surface area, hey guys, I don't want to lock your computers because sometimes it doesn't unlock and we waste like 5 minutes trying to unlock it. So just give me like 3 minutes to chat about the notes, what you have now in your possession, and then I'm just going to let you do it, okay? So, and this is the end of 7th grade, by the way. This is the end. Bye-bye. Move on to 8th grade, but don't worry, I'll still be here. So, 3-dimensional objects exist in 3 dimensions, just like all of us, which is really where, okay, so this piece of paper, is it 2-dimensional or 3-dimensional?
3-dimensional.
Yeah, see, we get stuck thinking it's 2-dimensional, because you think it doesn't have height, but, is this 2-dimensional or 3-dimensional?
3.
So it was 3-dimensional even when it was a flat piece of paper. The height was just very, 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 very small. But it still existed. And if we call that height layer 1, whatever unit that we're in, as we start to change its dimensions and stack it up, now we can actually start to see the volume of this object based on, well, how big is it still? and then how many stacks do we have? And that's exactly where we get our rule for volumes of any type of prism. So any type of prism means anything with two matching bases. So base does not mean bottom. Base does not mean bottom. Base does not mean bottom. Because this is the biggest confusion people have. Because I'll say, what's the base of that shape? And they say rectangle. And I'm like, no. The rectangle's on the floor. It's down. But what's the base? Base has to be matching on both ends. So that rectangle doesn't even have a match. Even if the rectangle had a match, the other rule with prisms is we are connected by rectangles. So if you decide you want to highlight some of this, here's a fun, I already get past the fun vocab word, polyhedrons. That's just a fancy vocab word if you want to try to impress some people. So a prism is a specific type of polyhedron. Polyhedron is really essentially any 3D object bounded by polygons, right? Squares, triangles, rectangles. So pyramids are polyhedrons, prisms. Like we got a lot. Our lateral faces are the rectangles. So that you might like honestly want to highlight because we talk about our bases and our lateral faces. We got bases, there's two of them, and lateral faces, they're on all the sides connecting your bases together. So the base is whatever shape is cloned on both sides, connected by rectangles. On both sides. So then, we'll give a little love to pyramids real quick. Pyramids are not prisms, because first off, they don't have matching bases. Second off, they're not connected by rectangles. They go to an apex point called the vertex. So apex, vertex, we can kind of use those interchangeable. And we'll get to volume of pyramids. We don't actually have to cover it in our 7th grade level of this. But if you want to write it down just so it's gotten in your brain once, the volume of a prism. Should I do this the fun way?
Yes.
Okay. I wasn't ready for anything. Go ahead and start your con for a moment. Then we'll come back to the notes. With me. You see. What kind of prism do you guys want me to use?
Yes.
Square?
Yes.
Pentagon? Hexagon?
Yes.
Ooh, let's just use cylinder. Because a cylinder is kind of like a prism. It's like a special type of prism, right? So if we think about the surface area of a cylinder, and volume is still the same rule of big B times H, which I guess is worth, if we look at the bottom, yeah, the very bottom of your paper here. Volume of any prism and cylinder, because it kind of counts like a prism, is the base area times however tall it is. Height is not necessarily vertical. Height is not necessarily vertical, because if I lay this on its side, the height is still the distance between the circles. So, volume. How could we discuss volume without a little bit of volume? So,
If you swirl it,
I gotta make sure it's full.
I think that's cool. I think that's cool.
Good. You should never be prepared for this class. Keep you on your toes. I wasn't aiming for you. I'm just trying to keep you on your toes. Alright, so I have a full cylinder of water. Which do you think would hold more, the cylinder or the pyramid? Now this cone, same basic idea as pyramid, right? This cone is same height. Same height as this. So which do you think holds more, the cylinder or the cone?
Cylinder.
The cylinder. That's kind of obvious. I want you to turn to a neighbor and hypothesize how many times could that cylinder fill up this cone. Same circle, right? So if I do this, kind of looks like a rocket ship. Same circle, right? Same height. How many times could that cylinder fill up that cone? Chat with each other. What do you think? How many times do we think that cylinder could fill that cone?
At least zero.
All right.
Zero.
Who's guessing between 1 and 2? Like it is less than twice. I could not fill it. Who's guessing twice? That this cylinder will fill the cone twice. Okay. Who's guessing between 2 and 3? Like 2.5, right? Like 2.25. Who's guessing 3? So here's the fun way that you guys, I think, have done in science a little bit. Because I'm not perfectly full, I'm not going to pour out, especially because I can't pour out nicely. What's another way that we can measure volume, like of a weird object, using like a graduated cylinder? Put it in the thing, right? Displacement. And this is also really fun because I can make sure that we've displaced everything we need to. So, all right, make another guess now. My cone is in my cylinder. I've got water left inside of my cylinder. When I pull my cone out, how much of the cylinder will be left?
There's a lot more than I expected.
I displaced a cone worth of water. I displaced doing the Dairy Queen thing, right? Flip it over. Okay, so that was one cone, right? Would anyone like to adjust their guesses now?
Yeah.
How many people are guessing between 2 and 3? Because there's 2.
There's gonna be how many? I'm guessing 3, 4, 3, 4, 3.
It's perfect. I'm not joking. This relationship is that a pyramid or a cone is perfectly, guys, this is my favorite lesson of the, well, maybe not favorite lesson of the year, but I get to play Willy Wonka, like Gene Wilder, that's one of my favorite songs too. And I get to play with water like I'm a science teacher, because I almost went science and math. If you care to write this down so you got it, pyramids and cones, perfectly a third of the related prism. So this would work also. If I grabbed my square prism, except they got stuck in here. I hope you guys have seen nets before, right? Nets of 3D objects. This should have happened last year. So this is where this gets sketchy. And why I guess I appreciate that I have carpeted floor. So we again displace, right? Let's displace one pyramid, right? We've got it displaced. Now we left the net in the pyramid so you can see it. So then, how much water should have come out of the prism? A third of it, right? So I should be able to, 2. Right, there's my second. Gotta watch out for that meniscus. Fun, that's like one of my favorite science words. Third, meniscus, it's where the water hits the very top edge, or where the water hits the side of the graduated cylinder and makes the little, like, the bend. And there's your 3. And there's your 3. Yeah, I know, there was some dust down in this bin, so this water is not clean anymore. So, it's guys, this is one of those math things where it's like, okay, we're in 3 dimensions, and the relationship is perfectly 3 or 1/3. Like, it's kind of cool. You gotta admit, it's sort of cool.
It's not sort of cool, it's awesome.
But you don't even need to care about pyramids and cones yet. We get into that in 8th grade. I just like doing this.
Later this year, it can matter.
Yeah, like next week.
Okay. I don't know.
Next week is 8th grade. Thank you very much.
By 8th grade sometimes. Sometimes it's like, is it 9th grade math or is it 8th grade math?
All right, so go ahead and try that con activity, the surface area volume. I want to know what you start getting tripped up on. I want to know what you start getting tripped up on.
What?
Ooh, Caroline, don't change from that slide. So Caroline is hitting a problem that helps us recognize not every prism is nice and not every base is the bottom. So I don't know how many of you have made it far enough in the activity to see this. Something similar. So, is the base the bottom here? No. Now, you have two options. Well, you probably have more than two options. You could cut this into two different boxes, right? Treat it separately. Or, you can look at the base as being this front awkward two rectangles. But your height, you guys use the handout. This is why I make handouts. We're not going to talk about everything on the handout because you can read. The height, as it says on the handout, is the distance between your bases. Now, that height really matters for volume. If you're only being asked for surface area, we can break this apart and think about the net. But on a lot of these problems, we're having to figure out a missing dimension. What is this missing dimension, and how can I figure that out? Carter?
The missing dimension is 0.25, and you can figure it out by getting the height from the full square and subtracting it from the 7 square on the left.
Look for what you know to figure out what you don't. Okay? So I want us to take probably at least 10 minutes to try some of these problems. I want to know what's tripping you up. So I just wanted to talk about this one because I saw Caroline looking at it, and I know this is one of the tougher ones. You should have some graph paper in front of you. There is a very, very slim chance that you could keep all these numbers in your head. You're going to need to write some things down. And it's easier to write it down than it is to try to keep it all typed out or in a calculator or something. You should have some graph paper in front of you. I'll even walk around and put graph paper in front of you so that you have graph paper in front of you. You're welcome, but more so it's that I want to control that, yes, you have graph paper to write on. It's not really me being nice. It's me wanting you to... you're using a whiteboard. I don't care. Whiteboard works also. So you like the whiteboard. Yeah, whiteboard is also an option. They're up front. I got tons of markers. Just going to need you to write down some numbers. There's a lot of numbers to keep track of.
Yes.
Little ditty I made up just for you guys.
I heard that too.
I guarantee I can't do it exactly the same again. We should have graph paper in front of us right now. I can't tell whose graph paper is.
This is mine.
You guys are definitely allowed to be using calculators right now. That should not be a question. Alright, so, essentially, because we're just trying to wrap up 7th grade, what I have planned for the rest of class, which isn't, like, I mean, it's like a half hour, right? A little over a half hour. It's a good chunk of time to get stuff done, but here's your priority list. Because the canteen is tomorrow, if you're red, you should definitely be kind of in, like, panic mode of, like, I gotta get stuff done if I want to do the canteen. So if you check math and you're red, that ain't good. Now, last year we operated gotta be green to go to canteen, because it rhymed. I think Pettigrew said yellow's okay?
Yeah.
Is that what she has communicated? See, this is one case where I was actually going to be meaner than Pettigrew and say yellow. You'd have to have like a conversation with your advisor. But if you're red, you need to be trying to take care of that. So late practice work. Guys, some of this isn't in math yet. And I probably won't put it in tonight because I'm not trying to be mean. I'm not trying to play gotcha and all of a sudden you're not allowed to go to the canteen. That's not cool. But I am putting it in this weekend, right? So quiz 2, I don't think is even in math yet. Quiz 1 is. I don't think quiz 2 is in math yet. Quiz 3 for sure is not. Like none of this stuff down here is. But this should be our priority list in that order. So don't take quiz 3 before you take quiz 2. And quiz 3 is really just a checkpoint to make sure that you're ready for the unit test. The 7th grade course challenge is not like assigned yet. Like guys, only what I assign as homework needs to be done outside of class. But if you're looking for something else to do and you want to get points for your class, speaking of, we should check con because we kept forgetting and 3B didn't. I think maybe, but like this week, I feel like 3B checked some day that you hadn't. What's up?
Is there a way to remove the unit test? That's on the wrong class for math.
What?
So, yeah, this is at the unit test is missing.
Divided by 2, right? For triangles, base times height divided by 2. For example, for anyone struggling with this, hey, for example, and this is going to be in the video, but yeah, a few of you were looking at this same problem. Guys, this is where setting up your work gets so important. My big B, my base here, are these triangles. And I'm just drawing back here so I'm not drawing on top of it. I have a little b and little h for my triangle that are part of the 2D shape. So when I go over here to talk about the volume of this whole shape, I'd have base times height divided by 2. That would give me that area, my big B. If you look at your handout, you know what big B is. Sounds like a rapper name if you ask me. We don't know what the height is. That's the height. Even though it doesn't look like it, that's the height of the prism, because if you stood it up on its base, that's the height. So now we plug in what we do know, 0.35. I don't need my units inside of my work. 1 times 0.5 divided by 2, and do the algebra to figure out what h is. I'm not going to walk you all the way to the answer. There's your setup. Here's your triangle area. That would be your big B. We know prism volume is big B times h. So we need to figure out what this is. And how do we isolate the h here? What would we do to both sides then? How do we undo multiplication? You're going to divide. So these are not just length times width times height. Sorry. We got tougher. This is not just length times width times height. Anyone else got a request? Requests. Vivian. No, DJ Hudcap takes song requests. Mr. Hudson takes math requests. Vivian. Zach. Ooh, Pet Chameleon.
Oh.
Yeah, I love that you guys are helping each other. Keep that up.
Can you help me on this one? The one I won?
Nope. Because Vivian got a request in first. But after this one, probably. If you're willing to wait. Otherwise, if you try it on your own first, you might just figure it out.
I just like don't.
There's sand in the bottom of the terrarium that reaches a height of 8 centimeters. Again, on my graph paper, I'd probably draw like a little picture. I guess if I'm trying to use some more accurate color, this is sand. Oh, sand for my chameleon. Okay, and that's 8. What does it actually want to know here? I think I did not capture the question. So if Zach uses the same sand that he did have, how deep will the sand be in his new terrarium? So we first, I'm again not going to do this whole problem for you, but we first need to figure out what's the volume of the sand that I have right now, which is funny because I was just saying this is not just length times width times height work. It's not just length times width times height, but here, this, because it's a prism, and it's a rectangle prism, I can do length times width times height. 20 times 50, 1,000? Times 8? 8,000 centimeters. That part I will walk you to. Because then what we have to do to that is imagine, with the new aquarium, drawing in 3 dimensions, maybe. Here's the bottom, and it measures 64 by 25. And what they're asking us to figure out is when we think about the three-dimensionalness of it, how deep will the sand end up now? So we got to figure out, well, I've got this volume, I've got these new dimensions, how deep will the sand actually go if I just dump the same sand in? Does that help you figure out what to set up on your paper? Hold on, Lila had it. Was it Lila over here? Something, right? Yeah, Lila. This is the problem everybody loves. The tent problem. You just sounded like the... Is it Monday Night Football? The da-na-na, da-na-na. I think it's just... But when you said no, 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 it sounded like no, no, no. Alright, Cyrus is buying a tent. There are better tent designs than this these days, but this is the old, reliable A-frame tent. So they give us the volume. It's 4.5 because they're measuring in meters cubed. Guys, to give you some perspective, a meter cubed is a meter wide, a meter long, and a meter tall. 1 meter cubed is big. A cubic meter is a large amount of whatever. Here we're just talking about like air inside of the tent, but if you're ordering like stone, like rocks for a pathway or something, those are measured in cubic yards because we're American, but it's pretty much the same. All right, so we know the volume inside of it. Can we, Lila, can we figure out our big B with the info we've been given? Do we know the height of this triangle? No. So there's the problem. I know my volume formula here. I think this is on the back of the handout. I left my notes over there. I think I did triangular prism on the back of the handout. But now the image that I could find says half of base times height. Well, I can't tell if you actually want this problem or not because you keep staring somewhere else. So I'm going to call it base times height with two different h's. You guys might want to be paying attention because this is a tough problem. This is what we're calling the base of our triangle, not big B. Like, not big B.
Please have Thomas Lilith to the Perry office for just a moment. Thomas Lilith to the Perry office.
This is where things get so difficult. We're talking about height in two different ways. We're talking about base in two different ways. You gotta write this stuff down, guys. My triangle, I only know one piece of it, which is its quote-unquote base. Now, you could also set up triangle formula as base times height divided by 2. But when we're doing all the algebra, this might be easier. Because how could I get rid of that half on both sides? Well, actually, I can go ahead and fill in the volume. We know the volume's 4.5. Oh, this one using X is going to be tricky. I'm running out of space. Whoa, not what I wanted to do. Guys, this applies to pretty much all these problems. So I want you to pay attention now, so hopefully I don't have to stop you as many more times. I know the base of the triangle. I don't know the height of that triangle. I do know the height of the prism, which is 3. So I know all of these pieces. I only have one unknown. It's time to algebra now. Multiply the numbers that we have on the right side, and then figure out what we need to get rid of. And since that's multiplication, how are we going to get rid of it? Division. So once we have whatever number is multiplying by this h, because it's 3 times a half times 1.5, right? Commutative property, I can move numbers around. That's equal to 4.5. I don't want to walk all the way to the answer because we need to make sure that we can do this algebra. This is reviewing our one-step equation type. Yeah, you got some math to do because I don't have a calculator out here. There's like a dozen right there that you guys can have, but I'm not going to get one. Does that help? I can help you more, but I'm not going to do it in front of the whole class. But I won't help you more until that's written down. Yes. Maybe. Once Lila has a chance to write this stuff down. So, Arnya, I don't think we actually need to do this problem. I think you just need to get some perspective. If this sugar cube, we're doing the giant sugar cube problem if you've seen that yet, or if you then go back and watch the video. So, cube, what do we know about cubes? Give me anything we know about cubes. 6 side faces, we call them now, but thank you, you're right. 6 faces. What about the faces? They're all the same. What did they give us in that problem? Volume or surface area? That surface area is of all 6 faces, and each face is identical. So could you do some algebra to figure out the area of one face? By. Then that's the area of one square face. Once you have that, how could you get one edge? Well, let's do 13.5 divided by 6. Go ahead and do that. What'd you get?
I got 2.25.
2.25. That's the area of that face, right? So unit squared, if you want to call it that. I need one of these edges, which is the root of this square, right? Because the edge is what we call the root. The root of this square, use square root. So if you square root your area, that's going to give you the edge length. Guys, this is end of 7th grade. It's putting a lot of stuff together. We're putting a lot of stuff together now. Lydia.
1, I did the missing work.
Great. Email me.
Okay, and 2, I'm really confused on the problem.
Wait, what are all those E's? Arnya, I think you might want to grab a handheld calculator. It might be easier. Because I don't know if typing in SQRT works on those calculators.
Well, I pressed square root and then it did that.
Where'd those E's come from, though? I'm confused about that. Well, now it's gone, but for a second, your calculator view looked really weird. Yeah, I don't know what it's doing. Oh, for some reason it was clicking exponent. Yeah, I would just use one of the handheld calculators. I don't always trust the online ones to like do what I want it to do, because you got to make sure you type things in real carefully. Lydia. Oh, you don't need my help with this. Lydia. I'm not going to help you. I'm only going to ask you questions. But I guess if you consider that helped, then maybe I am going to help you. If we're covering this entire cake, because Lacey's mom is crazy, she's even going to do the bottom. I don't know how you ice the bottom of a cake, but I guess maybe like ice it and then flip it, maybe. What are we talking about here? Surface area or volume? Surface area. You already figured out your unknown dimension by doing that subtraction. So you know all the dimensions of all the different pieces. Could you figure out this top? Yeah. It's 10 by 5, right? This is where you're going to have to write some things down. Because that's just one piece of the top. Here's another piece of the top. We're going to need to write that down and keep track of it. Then, and I would write on your paper like top equals like this plus that. Right? Your right side is also broken up. Your right side has this piece and this piece. But, guys, still, look at this. Like Lydia, hold the calculator like those two top pieces. Would still add up to be the same as the bottom. Those two right pieces would still actually add up to be the same as the left. Right? Because all they did was they took the rectangle and they broke it apart and they moved a part of it over. So you can still do like, if I get the left side, the right side is the same. It's just in two pieces. But it's like, so this is 30 by 5, right? This side should total up to be 150 because it's the same. It's all about visualizing these 3D shapes. So for your front and back, those are the trickier part. I'm going to give you time to work because these are not fast problems. That's also why I dedicated like a double block class to do this. These are not necessarily quick problems.
The top and the bottom are 110.
I don't know. Evie, I'm going to put it up front or just come look at what you got? Ooh, you're making this more difficult than it needs to be. When we come back into this step, let me grab a poster. Like what you're doing is fine, but I think you tripped up somewhere because you made it more difficult. Instead of starting by trying to get rid of that 3, let's just put all of the numbers on the right side together first. So we're going to leave that 4.5 alone. I don't have a real pencil on me. So go ahead and multiply 1/2 times 1.5. You got small lens, almost bright light. Now we're going to do times 3, because we also have that 3 over here. We move all the numbers next to each other, so hit times 3. What you actually have is that. Or, sorry, little h. Because if you put these 3 numbers together first, then you just have a one-step equation. What can you do to solve that one-step equation?
How do you do this again?
Yeah, that.
Oh, so you I think you added it and
These are what we call rigorous problems. It's not just like punch it into a calculator. Like you got to actually think, guys. We got to turn our brains on. What are we trying to do? What are we trying to solve? What do we know? Right now, it's just like work on it if you got extra time. Yeah, it is not assigned. You do not have to do it. But it'll get you a lot of points towards the Learn Storm, which we should check.
You get a point per assignment or
Mastery of a topic. Like mastery of a skill.
So let's say you need to do the assignment.
I mean, kind of, yeah. Hey, Lila. Who's your advisor? Can you bring me your computer again so I can check your math?